So this is video number 5 in a series of 9 to help you with the number patterns questions. So we've got a pattern that goes, I've called it U equals, so the first term is 7, the second term is 10, the third term is 15, the fourth term is 22. So what's the pattern here? Well, it's not going up by a fixed amount every time, because it goes up by 3 and then up by 5 and then up by 7. So it's not an arithmetic sequence. And it's not multiplying by a fixed amount every time, because 10 divided by 7 isn't the same as 15 divided by 10, which isn't the same as 22 divided by 15. So it looks like, OMG, shock horror, it's the dreaded third type, the quadratic sequence. But let's have a look. So the differences between the terms are going +3, +5, +7. And you're starting to see a pattern there, because the differences between the differences are 2 every time. So the actual differences are going up by 2 every time. So you've got the, well, they're called the first difference, and then the second difference is 2 every time. So we can use that to predict the subsequent terms in the sequence. So the next one should be going +9, if I can get my pen to work. So +9 should give us 31, and then +11 should give us the next one, 42. +13 should give us the next one, 55. And +15 should give us the next one, 70. So that's our predictions in the table. Now let's have a look at how we're going to crack the algebraic rule for that. Well, first of all, before I do that, let's write down some patterns in words. So you can talk about the second differences. So that is a term that's recognized. So the second difference between terms is always 2. And what else could be right? Well, alternately the numbers are odd, even, so perhaps we could make that observation. So the numbers alternate between odd and even. That's a fair enough comment to make. Okay, so the fact that you've got second difference is constant tells you it's a quadratic sequence, and we were getting the second difference to be, so it was going 3, 5, so the second differences were 2. So let's just try n squared as the rule. So if n squared were the rule, then you'd get 1 squared, which is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So the differences between the differences would go +3, +5, and the second differences would indeed be 2 every time. So it's going +7, second difference +2. So it looks like we're good with the n squared. So let's start off with n squared as part of our rule. Now, by the way, I wouldn't be attempting to write all this in the response box in the exam. I'd just be kind of doing this on a little bit of scrap paper at this stage. But let's just do that and tidy that up. So let's think about n squared. 1, 4, 9, 16, 25, 36, 49, 64. Now obviously that's not giving us the numbers we want, but let's look at how much we're missing from the numbers we want. So for the first number, we're getting a 1 when we want the term to be 7, so we want to get an extra 6 from somewhere. Then we're getting a 4 when we want a 10, so we want to get an extra 6 somewhere. And in fact, all of these, we're just missing 6. So the rule in this case is just n squared plus 6 gives us the numbers we want. So let's write that in. So our rule is u equals n squared plus 6. And now let's test and verify that rule. So testing the rule, when n equals 6, my rule says u equals n squared plus 6, which is, sorry, when n equals 3, did I say 6? When n equals 3, my rule says u equals n squared plus 6, which is 3 squared plus 6, which is 9 plus 6, which is 15. That matches the value in the table. So make the observation, this matches the value in the table. And then verifying is just doing the same thing, but for one of these higher up values where you yourself had to make the prediction for what goes in the box. So when n equals 7, my rule says u equals n squared plus 6, which is 7 squared plus 6, which is 49 plus 6, which is 55, and that matches what we get in the table. So we don't want to forget to make that observation. This matches the value in the table to ensure that we get the full mark for that. So there's that, and we're pretty well done with that question, and maybe we've picked up about 30 marks in 5 minutes there, hopefully.